Welcome to today's lesson story about space and time. We will explore how scientists understand the universe using physics and observation. This text also comes with a free PDF including the story, important vocabulary, and a short quiz to test your learning. Let's begin our scientific journey into space-time. Space and time are two of the most important ideas in modern science. In the past, people thought that space and time were separate. They believed that space was where objects were located, and time was just a clock ticking everywhere the same. However, science has shown that this view is not correct. In 1905 and 1915, the famous scientist Albert Einstein developed new ideas about the universe. His work is called the theory of relativity. According to this theory, space and time are not separate. They are connected and form a single structure, called space-time. This is one of the most important scientific discoveries in history. Space-time can be imagined as a flexible sheet or fabric. When a heavy object like a planet or a star is on this sheet, the sheet bends. This bending is what we feel as gravity. It means that gravity is not just a force pulling things down. Instead, gravity happens because objects move along the curves of space-time. Scientists have tested these ideas many times. One famous experiment happened in 1919 during a solar eclipse. During an eclipse, the sun is covered by the moon, and stars near the sun become visible. Scientists observed that the light from these stars was bent as it passed near the sun. This bending showed that the sun's mass curves space-time, just as Einstein predicted. Understanding space-time is important for many reasons. It helps explain how planets move around the sun. It helps scientists understand how galaxies are shaped. Without relativity, it would be impossible to explain why GPS systems work correctly. GPS satellites move fast and are high above the Earth. Their clocks are affected by both gravity and speed. Scientists must use Einstein's equations to adjust the time, or GPS would give wrong locations. Another important point is that studying space and time allows scientists to look into the past. Light travels at a fixed speed. When we look at a star that is very far away, the light we see left the star a long time ago. Some stars are millions, or even billions of light years away. This means we see them not as they are now, but as they were millions or billions of years ago. In this way, telescopes act like time machines. They help us study the history of the universe. In conclusion, space and time are not simple ideas. They are connected and dynamic. They shape the way the universe works. Understanding them allows humans to explore not just the present, but also the deep past of the cosmos. Einstein's theory of relativity shows that time is not the same for everyone. Time can move at different speeds for different observers. This effect is called time dilation. It happens when an object moves very fast or is in a place with very strong gravity. A famous thought experiment explains this idea. It is called the twin paradox. Imagine two twins. One stays on Earth. The other travels in a spaceship close to the speed of light. When the traveling twin returns, they are younger than the twin, who stayed on Earth. This happens because time passed more slowly for the twin in the spaceship. This is not just a story. It is based on real science. Time dilation also happens near very massive objects like black holes. A black hole has gravity so strong that it bends space-time extremely. If an astronaut spends 1 hour near a black hole and then returns to Earth, many years could have passed on Earth. This effect has been confirmed in science using very precise clocks. Scientists have tested time dilation with airplanes and satellites. They put atomic clocks on fast airplanes and compared them with clocks on the ground. The moving clocks showed a small difference in time, exactly as Einstein predicted. This shows that relativity is real and affects our daily lives. One very practical example is the Global Positioning System, GPS. GPS uses satellites that orbit Earth at high speeds. Their clocks run slightly faster than clocks on Earth because of gravity and speed differences. If scientists did not correct this using Einstein's formulas, GPS systems would show wrong positions by several kilometers every day. Thanks to relativity, your smartphone can tell you where you are accurately. Time dilation also helps scientists study the universe. Light from distant galaxies travels for billions of years before reaching us. During this time, space itself stretches. This stretching changes the color of light, an effect called redshift. By study, the idea that time can slow down or speed up may sound strange. However, it is one of the most important results of modern physics. It shows that time is not fixed. It depends on motion and gravity. This discovery changed our understanding of reality. In conclusion, time dilation is a key part of Einstein's relativity. It explains strange but real effects that happen in space and even in technology we use every day. Understanding time dilation helps us explore the universe and build accurate scientific tools. Black holes are among the most extreme objects in the universe. A black hole forms when a very massive star uses all of its fuel and collapses under its own gravity. When this happens, the star becomes very small, but its mass stays the same. The result is an object with gravity so strong that not even light can escape. At the center of a black hole, there is something called a singularity. A singularity is a point where our current laws of physics cannot explain what happens. Around the singularity, there is a boundary called the event horizon. If something crosses this boundary, it can never come back. That is why black holes are called black. No light or information can escape from inside. Black holes are important for science because they help us test the limits of Einstein's relativity. In 2019, scientists took the first real image of a black hole using a network of telescopes all over the world. This image showed the shadow of a black hole surrounded by glowing gas. The results matched what Einstein's theory predicted more than 100 years ago. Black holes are not rare. Many galaxies, including our Milky Way, have a supermassive black hole at their center. These black holes are millions or even billions of times heavier than the Sun. They affect the motion of stars and the growth of galaxies. Scientists believe that without these giant black holes, galaxies would not have formed as we see them today. Another interesting idea is the concept of wormholes. A wormhole is a possible tunnel through space-time that could connect two very distant points. Wormholes are solutions to Einstein's equations, but scientists have not found real evidence for them yet. If wormholes exist, they might allow faster travel between stars or even time travel. However, these ideas are still theoretical and need more research. Black holes also help scientists ask deep questions about information and the universe. What happens to matter and energy when it enters a black hole? Can the information ever escape? These are open questions in modern physics. Some scientists study quantum mechanics to understand this mystery. In conclusion, black holes are not just science fiction. They are real objects that help scientists test the most extreme laws of nature. Studying black holes teaches us about gravity, space-time, and the early universe. They also open the door to exciting future discoveries. The universe is not static. It is growing and changing. In the early 20th century, scientists thought the universe was fixed. However, in 1929, astronomer Edwin Hubble made an important discovery. He observed that light from distant galaxies was stretched toward the red part of the spectrum. This effect is called redshift. Redshift happens when objects move away from us. It showed that galaxies are moving apart and that the universe is expanding. The expansion of the universe means that space itself is getting larger. If we look far enough back in time, the universe was much smaller and hotter. Scientists call this beginning the Big Bang. According to current research, the Big Bang happened about 13.8 billion years ago. From that moment, time began to move forward. The expansion of the universe also helps us understand something called the arrow of time. Time seems to move in one direction, from the past to the future. We remember yesterday, but we cannot go back to it. We can plan tomorrow, but we cannot see it yet. Physics explains this with the idea of entropy. Entropy is a measure of disorder. According to the second law of thermodynamics, entropy always increases in a closed system. This increase gives time its direction. Another mystery is dark energy. Observations show that the universe is not just expanding, the expansion is speeding up. Scientists do not know exactly what dark energy is. It acts like a force that pushes galaxies apart faster and faster. Dark energy makes up about 70% of the total energy in the universe, but we cannot see it directly. It is one of the biggest puzzles in modern science. What will happen to the universe in the future? There are many ideas. If expansion continues forever, galaxies will move farther apart until stars burn out. This idea is called the heat death of the universe. Another possibility is that expansion could slow and reverse, causing the universe to collapse again in a big crunch. For now, evidence supports continued expansion. Studying the universe's expansion and the arrow of time helps scientists ask big questions. Why does time only move forward? What is the ultimate fate of the universe? These questions connect physics, philosophy, and even our understanding of life. In conclusion, the expanding universe shows us that space and time are dynamic and connected. By studying redshift, entropy, and dark energy, scientists explore the past and predict the future. Time's arrow moves forward, and our knowledge grows with it. Space and time connect science and imagination. From black holes to the expanding universe, they show us how amazing reality is. We hope this story helped you learn new ideas in simple English. Don't forget, you can download the PDF with vocabulary and quiz to review and test yourself. Keep exploring the universe with us.